All right, welcome to the Advanced Concepts section of Module 3, Code, Documentation, and Compliance. So here's where we are. You've already built a solid foundation. You know the frameworks, the standards, and the basic rules. That's great, but now we're going to take all of that and crank up the complexity, because that's exactly what NCARB does on the actual exam. They don't just ask you to define a term. They give you a scenario with competing priorities and ask you to pick the best move. We've got 10 slides ahead of us, broken into 5 sections, and each one is designed to push your thinking from, I know the concept, to, I can apply it under pressure. So let's preview what's coming. Section 4.1 tackles complex code scenarios, mixed occupancy, high-rise provisions, atrium design. Section 4.2 tackles advanced egress strategies, horizontal exits, areas of refuge, phased evacuation. Section 4.3 tackles performance-based design, alternative compliance, fire modeling, equivalency methods. Section 4.4 tackles accessibility beyond minimums, universal design, historic buildings, alterations triggers. Section 4.5 tackles jurisdictional variations, state amendments, local overlays, plan review strategies. Here's the thing about these topics. This is where most candidates lose points on the exam. Not because the material is inherently harder, but because the questions require judgment, not just recall. You can't memorize your way through these. You've got to think through scenarios, weigh competing interests, and pick the best answer when multiple options seem reasonable. So let's start building that skill right now. Basic egress is straightforward. Count the people, size the exits. But the exam goes deeper. You need to understand the 3 critical distance measurements that limit how you can plan your building: travel distance, common path of egress travel, and dead-end corridors. Getting these confused is one of the most common exam mistakes. The 3 distance limits table is one of the most confused topics on the exam. Travel distance is measured from the most remote point to the nearest exit. Common path of egress travel is the distance before paths diverge to 2 separate exits. Dead-end corridor length is measured from the end of the dead end to the point where 2 directions are available. Each has different limits, and they must be checked independently. Getting them confused is one of the most common exam mistakes. The maximum travel distance table varies by occupancy and sprinkler status. Most occupancies get 250 feet with sprinklers. Business occupancy gets 300 feet, the most generous. High hazard H1 is only 75 feet, even with sprinklers. Always check this table against your specific occupancy. Sprinklers consistently add 50 feet to the allowable travel distance. How travel distance is measured. Travel distance is measured along the natural path of travel, not in a straight line. It follows the center of corridors, goes through doorways, and accounts for furniture layouts in open areas. On the exam, trace the actual walking path on the plan. Here's the key insight. Common path of egress travel is not the same as dead-end corridor. Common path applies to any space, rooms, open floor areas. Dead end applies only to corridors. Both limit how far you can travel before you have 2 independent exit options. Having the right number of exits means nothing if they're all in the same corner of the building. Exit separation rules ensure that if one exit is blocked by fire, the other exits remain accessible from a different direction. When 2 exits are required, they must be separated by a minimum distance equal to 1/2 the maximum overall diagonal dimension of the building or area being served. In sprinklered buildings, this is reduced to 1/3 the diagonal. The exit separation requirements table explains the half-diagonal rule. In a non-sprinklered building, 2 exits must be separated by at least 1/2 the maximum diagonal dimension. In a sprinklered building, this reduces to 1/3 the diagonal. For 3 or more exits, they must be reasonably spaced and dispersed. Calculate the diagonal first, then determine the minimum separation distance. When multiple exits are required, the total occupant load must be distributed among the exits. But you can't just divide evenly. You must assume the largest exit is blocked. Here's the key insight, the lost exit rule. When 2 exits are required, each must be capable of handling the entire occupant load. 50-50 distribution means each handles 100% if one is lost. When 3 exits are required, the total capacity minus the largest single exit must still accommodate the full occupant load. Exam calculation. For a space with 400 occupants and 2 exits, each exit must handle all 400 occupants. Stair width equals 400 by more 0.2 inches, sprinklered, equals 80 inches. Check minimum, 44 inches. 80 inches over 44 inches, so 80 inches governs. Each stair must be at least 80 inches wide. Fire-rated construction is where code documentation gets most complex and most consequential. The wrong rating on a wall assembly can fail plan review. The wrong assembly in construction can cost lives. Understanding the hierarchy of fire-rated elements and their documentation requirements is essential for PDD. The fire separation hierarchy table is essential to understand from most to least restrictive. A firewall creates separate buildings and must be structurally independent. If the building on one side collapses, the wall stands. A fire barrier separates occupancies and exit enclosures, but is not structurally independent. A fire partition is typically 1 hour for corridors and dwelling units. Smoke barriers and partitions restrict smoke movement with decreasing levels of protection. Firewall versus fire barrier. The exam loves this. A firewall creates separate buildings for code purposes. It must be structurally independent. If the building on one side collapses, the wall stands. A fire barrier is a rated separation within a single building, exit enclosures, occupancy separations, but is not structurally independent. Mixing these up is a common exam trap. The opening protective ratings table shows the relationship between wall ratings and door ratings. A 4-hour firewall gets a 3-hour door. A 2-hour fire barrier gets a 90-minute door. A 1-hour fire barrier gets a 45-minute door. A 1-hour corridor wall only gets a 20-minute door. The door rating is always less than the wall rating, roughly 75%. This relationship is tested frequently. Here's the key insight. The door rating is always less than the wall rating, typically 75% of the wall rating. A 2-hour wall gets a 1.5-hour door. A 1-hour wall gets a 45-minute door. The exam frequently asks you to match door ratings to wall ratings. Having the right fire ratings means nothing if they're not properly documented. During PDD, you need to translate fire protection requirements into clear, buildable information in the construction documents. This means wall type schedules, rated assembly details, penetration fire stop details, and life safety plans. The fire-rated construction documentation table shows every document that must carry fire protection information. Your wall type schedule lists all assemblies with UL numbers and ratings. The life safety plan shows rated walls graphically. The door schedule ties fire-rated doors to their hardware requirements. Detailed drawings show how rated assemblies maintain continuity at connections. Every penetration through a rated wall needs a documented fire stop system. Every item on this list represents a documentation error that will fail plan review. A rated wall on the plan with no corresponding wall type in the schedule is a gap. A fire-rated door without a closer or coordinator is incomplete. A rated wall that terminates at the ceiling instead of continuing to the underside of structure may not satisfy the fire barrier requirement. Review your documents against this checklist before submitting for permit. Here's the key insight. Every fire-rated wall in your building should be traceable. Plan shows the wall type schedule gives the assembly, detail shows the construction, UL listing provides the tested assembly. Break any link in this chain and you'll fail plan review. Most real buildings contain more than one occupancy group. A building with ground floor retail and upper floor apartments has both M and R2 occupancies. How you handle this mixed condition fundamentally changes your code analysis. The IBC gives you 3 approaches, and choosing the wrong one can make your building non-compliant or unnecessarily expensive. The 3 approaches to mixed occupancy table is critical for the exam. Accessory occupancies under 10% of floor area follow the main occupancy rules. Separated occupancies use rated construction between uses and each is analyzed independently. Non-separated occupancies require no rated separations, but the most restrictive requirements govern the entire building. Your choice between separated and non-separated fundamentally changes the code analysis outcome. The separated versus non-separated comparison table reveals the trade-off clearly. Separated occupancies require fire-rated walls between uses, but allow each occupancy its own allowable area and construction type. Non-separated occupancies save the cost of rated separations, but force the most restrictive occupancy requirements across the board. When mixing a permissive occupancy like B with a restrictive one like A, separated analysis almost always yields a better result. The accessory occupancy trap. An accessory occupancy must be less than 10% of the floor area and subordinate to the main occupancy. A conference room in an office building is not a separate A3 occupancy. It's an accessory use to B occupancy. But a 500-person auditorium in an office building exceeds accessory and must be treated as separated or non-separated mixed occupancy. Here's the key insight. The exam tests your decision-making. Separated occupancies cost more in construction, rated walls, but give you more flexibility in building type and area. Non-separated occupancies save on construction, but force the most restrictive requirements across the board. Always evaluate both approaches and choose the most economical path to compliance. When using separated occupancies, the IBC requires a special area calculation to ensure the building as a whole doesn't exceed safe limits. You can't just give each occupancy its full allowable area. They share the same structure, after all. This is where the ratio method comes in. For each occupancy, divide the actual area by the allowable area. Then sum all the ratios. The total must not exceed 1.0 or 100%. Here's the key insight. Sum of actual area of each occupancy or allowable area of each occupancy must be less than or equal to 1.0. Example, if A2 allows 15,000 cesfeet and you use 6,000 cesfeet, ratio equals 0.4, and B allows 25,000 cesfeet and you use 12,500 cesfeet, ratio equals 0.5, the sum is 0.4 and 0.5 equals 0.9. Since 0.9 less than 1.0, it complies. The required occupancy separation ratings table shows what fire rating you need between different occupancy combinations. Most common combinations, A and B, B and M, B and R, require 2-hour separation without sprinklers and 1 hour with sprinklers. High-hazard H1 combinations require 3 to 4 hours. Institutional I2 always requires 2-hour separation, even with sprinklers. Keep this table in mind when evaluating mixed-use buildings. Exam strategy. If the exam gives you actual and allowable areas for multiple occupancies, set up the ratio calculation immediately. If the sum exceeds 1.0, either the construction type must change, the building must get smaller, or modifications, sprinklers, frontage, must be applied to increase allowable areas. Here's where code knowledge becomes a design tool. When the base allowable area or height is too restrictive for your program, you have multiple strategies to increase it. Understanding these modifications is what separates a code-literate architect from one who just looks things up in a table. The Area and Height Modification Strategies table is your toolkit for making buildings bigger or taller. Sprinklers provide the largest area increase, up to 300% for single-story buildings. They also add 20 feet and 1 story to allowable height. Frontage increases reward open perimeter access up to 75% additional area. Firewalls divide a building into separate code buildings, giving each side its own full allowable area. The mezzanine exception lets intermediate levels avoid counting as a story if they stay under the area threshold. A firewall doesn't just separate occupancies, it creates separate buildings for code purposes. Each side of the firewall is independently evaluated for construction type, allowable area, and height. This is the nuclear option for area problems. If your building is too big, put a firewall through it and treat each side as a separate building. Firewall costs. Firewalls require structural independence. Each side must stand if the other collapses. Foundation to above the roof, and very limited openings. They are extremely expensive and architecturally disruptive. Use them when other modifications aren't sufficient, not as a first choice. Here's the key insight. The mezzanine exception is an underused tool. If a mezzanine is less than 1/3 of the floor area below, it doesn't count as a story or add to the building area. In a sprinklered building, this threshold increases to 1/2. This can save you from needing a higher construction type just because of a small intermediate level. New construction is straightforward. Comply with everything. Existing buildings are where accessibility gets complicated. When you alter an existing building, how much accessibility do you need to add? The answer depends on the scope of work, the cost, and whether you're changing the building's use. And the ADA and IBC have slightly different rules. The Accessibility Triggers table shows when accessibility improvements are required in existing buildings. Alterations to primary function areas trigger path of travel requirements up to 20% of alteration cost. Changes of occupancy or use require full compliance with the new occupancy requirements. Additions must fully comply, and the path from the existing building to the addition may need upgrades. Historic buildings have alternative minimum requirements. When an alteration affects a primary function area, the ADA requires the path of travel to that area to be made accessible. But there's a cap. You only need to spend up to 20% of the total alteration cost on path of travel improvements. If full compliance would cost more than 20%, you prioritize the improvements in a specific order. The priority order list tells you exactly how to allocate that 20% spending cap. First, provide an accessible entrance from parking or the public way. Second, create an accessible route to the altered area. Third, provide an accessible restroom on that route. Fourth, add accessible telephones, drinking fountains, and signage. This priority order means you address the most critical access needs first when full compliance exceeds the budget cap. IBC versus ADA on existing buildings. The IBC, Section 3411, and ADA handle existing building accessibility differently. The IBC ties requirements to permit-level work. The ADA applies to all alterations regardless of permit. A building owner can't escape ADA requirements by avoiding permits. The architect must advise the owner about both obligations. Here's the key insight. The 20% rule is a spending cap, not an effort cap. You must still design the most cost-effective path to maximum accessibility within that 20%. And the 20% is cumulative. Each time you alter the building, you spend up to 20% of that alteration's cost on accessibility improvements until the building is fully accessible. Automatic sprinkler systems are the single most effective fire protection feature in a building. Understanding the four main types and when each is required or appropriate is critical for both code compliance and the ARE. The NFPA 13 Sprinkler System Types table covers the four main systems. Wet pipe is the standard. Pipes always filled with water, fastest response. Dry pipe uses pressurized air in unheated spaces with up to 60 seconds delay. Pre-action requires 2 triggers, making it ideal for spaces where accidental discharge would be catastrophic, like data centers. Deluge systems have all heads open and activate the entire system at once for high-hazard areas. The IBC Sprinkler Requirements table shows when sprinklers are mandatory. Assembly over 300 occupants, educational over 50, institutional occupancies, residential occupancies, and any building over 55 feet, all require sprinklers throughout. Note that Group R residential now requires sprinklers in essentially all cases. High-rise buildings at 55 feet above grade also trigger mandatory sprinklers under IBC Section 403. Here's the key insight. On the exam, sprinkler questions often test the trade-offs, not just whether they are required. Sprinklers unlock area increases, height increases, reduced fire ratings, longer travel distances, and longer dead-end corridors. They are a code compliance tool, not just a safety feature. Adding a fully automatic sprinkler system, NFPA 13, is often the most cost-effective way to solve code compliance problems. The IBC rewards sprinkler installation with significant increases in allowable area and height, plus reductions in required fire resistance ratings. The sprinkler trade-off summary table shows the code benefits of installing sprinklers. Allowable area increases up to 300%. Height increases by 20 feet and 1 story. Travel distance extends from 200 to 250 feet for most occupancies. Dead-end corridors go from 20 to 50 feet. Egress width factors decrease. These trade-offs make sprinklers one of the most cost-effective compliance tools available, often cheaper than upgrading the construction type. Area increase formula. The allowable area increase formula is AA equals AT and NS times if and NS times IS, where AT equals tabular area, NS equals number of stories modifier, if equals frontage increase factor, IS equals sprinkler increase factor. The total increase from frontage and sprinklers is capped at 75% for multi-story buildings. Sprinklers alone give a 200% increase for multi-story and 300% for single-story. Here's the key insight. When a code question asks, how can the architect increase the allowable area? The answer is almost always sprinklers, frontage, or both. A sprinkler system is typically cheaper than upgrading the construction type, which is the other main strategy for increasing allowable area. Let's bring it all together. You've just worked through the entire advanced layer of project development and documentation Module 3, Code Documentation and Compliance. That's a lot of material, so let's recap what you've learned and why it matters. Section 4.1, Complex Scenarios. Mixed occupancy requires separation or accessory provisions. High-rise triggers add sprinklers, standpipes, and fire command. Section 4.2, Advanced Egress. Horizontal exits use fire barriers as exit elements. Areas of refuge serve occupants who cannot use stairs. Section 4.3, Performance Design. Performance-based design requires fire engineering analysis. The burden of proof shifts to the design team. Section 4.4, Beyond Minimums. Universal design exceeds ADA minimums for all users. Alterations trigger accessibility upgrades based on cost thresholds. Section 4.5, Jurisdictions. State amendments can override IBC provisions. Know your jurisdiction before assuming national code applies. The thread connecting all of these sections is this: project development and documentation isn't just about drawing. It's about producing coordinated, code-compliant documents that translate design intent into buildable reality. Get this right, and every construction phase that follows gets smoother. Your next step is the Advanced Check Quiz. These questions are harder. They test application, not just recall. Take your time, read each option carefully, and use the explanations to refine your thinking. When you finish this, you'll have completed the full Module 3 content. You've built a solid foundation. Time to put it to the test.